Most people building AI systems today start the same way. They write one really big prompt, they give the model access to a few tools, and they hope that somehow this single agent will be able to do the research, reasoning, analysis, and decision making all in one shot. That might work for a demo, but it usually falls apart in production. You start seeing hallucinations. The system becomes difficult to debug. And if something goes wrong, you have absolutely no idea which part of the logic failed. And if you want to improve one step of the process, you often end up rewriting everything. So in this video, we want to show you a different approach. Instead of one massive agent trying to do everything, we are going to build a structured multi-agent system where each and every agent specializes in one specific task. We'll build a project called Argus, which will act like an autonomous investment research committee. You give it a company or a ticker symbol, and it runs a sequence of agents that research the company, analyze the data, challenge the thesis, and produce a final research report. But the goal of the video is not really about finance. The goal is to show you how you can build production-style agent systems and how they should be structured. And we look at how specialized agents coordinate, how parallel execution reduces latency, and how you can run your agents as background workflows instead of just front-end chatbots. And by the end of this video, you will see how a multi-agent system can look much more like a distributed software system rather than just a simple prompt.
So let's start with what we're actually building. We're building a financial multi-agent system, and you can think of it like a small investment committee made up of multiple specialized agents. So the workflow looks something like this. First, we have the manager. The manager takes the user's query and turns it into a structured research plan. Once the plan is created, the system will split it into two parallel investigations. The first one is the analyst, which builds the bull case, which is the positive investment thesis. At the same time, there is going to be another agent called the Contrarian, which builds the bear case. The Contrarian's job is to challenge the assumptions, identify the risks, and search for weaknesses in the thesis. Now, once these two perspectives are complete, we will run two final synthesis agents in parallel. The first one is editor short, which will produce a short-term outlook roughly for about 1 to 6 months. The other one will be editor long, which produces a long-term outlook for about 1 to 5 year horizon. Then these two outputs are finally combined into a dual research report. So the final pipeline looks something like this. The manager sends it to the analyst and Contrarian, then it's sent to the editor short and editor long, and then we get the final report. So the key idea here is specialization. Each agent does one job. The analyst focuses on the fundamentals and the growth potential. The project also uses a hybrid model strategy, a larger 120 billion LLM for the reasoning heavy agents such as the manager, analyst, and Contrarian, and a smaller 20 billion parameter model for the editors. This reflects a real world production pattern where it means expensive reasoning where it's required, whereas cheaper synthesis where it doesn't. The Contrarian focuses on the risks and weaknesses, and the editor synthesizes both sides into final decisions. So this structure dramatically reduces hallucination risk and makes the system easier to debug and extend. So before we talk about the framework we used, I want to explain the methodology behind the system. Because the most important idea here is not the actual framework, it is the architecture of background agents. So when people think about agents today, they often think of chatbots. You type something, the agent responds, maybe it calls a tool, and that's the interaction. But so the most valuable agents are actually not chat interfaces, they are background workflows. In these scenarios, the agent is not primarily interacting with the human, it's executing a structured workflow. That changes how you design the system. You want the system to behave less like a chatbot and more like a distributed service pipeline. That's exactly how the project is designed. The manager plans the research, the analyst investigates the positive case, the Contrarian investigates the negative case, and the editors synthesize the final conclusion. Each and every stage here is independent, observable, and replaceable. So if the final report is bad, you can easily inspect which exact stage produced the problem. And this is the type of architecture in what basically makes agents viable for real workflows instead of just demos.
Now let's talk about the infrastructure we are using to build the system. The open source framework we are using is AgentField. And the reason I chose it for this project is that it approaches multi-agent systems from a slightly different angle than many other frameworks. Now, most traditional agent frameworks focus on defining agent workflows inside a single application runtime. For example, you define a graph of nodes, pass the state between them, and execute the workflow inside the same process. That approach works well for many applications. But AgentField is designed more like the infrastructure for autonomous systems. Instead of treating agents purely as workflow nodes, it separates the system into two different layers. Now, the first layer is the control plane. This handles the infrastructure concerns that every production system eventually needs. The control plane is written entirely in Go and is designed to scale horizontally. The next layer is the agent nodes. This is where the actual business logic lives. You write agents as typed Python functions, defining reasoners for AI-backed logic and skills for deterministic tools. Every agent gets a cryptographic identity, so in production, every action is signed and is verifiable and not just locked. So instead of building one monolith application that does everything, AgentField lets you build independent services or agent services that coordinate through the control plane. Now, another important detail is how these agents actually call each other. So instead of direct HTTP calls between agents, all coordination goes through the control plane via this app.call, making inter-agent discovery and routing more automatic. And AgentField also supports two different kinds of execution modes. Synchronous execution, where the agent runs immediately and returns a result within the request, and asynchronous execution, where the task is queued and processed in the background with a webhook callback when it completes. Especially important for real-world systems where the agent may run for minutes or even for hours. And that asynchronous pattern fits perfectly with the idea of background agents as we discussed earlier. So the reason I chose AgentField for this project is not just because it lets us to define agents. It's also because it provides the infrastructure needed to run these agents as real production services, without which you would need something like Redis for state, Kafka for async, and a service mesh for routing. Plus, you will have to build your own auth layer for your agents.
Now let's walk through the project itself and see how everything fits together. So the entire project is structured in a modular fashion. Each file has a specific responsibility. And the main components here are schemas, skill, reasoners, the streaming infrastructure, and the main server entry point. So let's go over schema. So schema is essentially a typed pydantic model that defines the structured input and outputs for the agents, enforcing validation and predictability at the infrastructure level. Next, we have the skills. So these are deterministic functions that run as independent callable microservice endpoints and can be invoked directly by reasoners or by other services. Let's also explore what exactly are reasoners. These are AI-guided decision functions that orchestrate skills and the other agents, combining the model judgment with typed schemas to create guided autonomy. And finally, we have this entire streaming infrastructure, which is a custom server-sent events layer that pushed type AgentField nodes and events over HTTP so that any front end can basically subscribe for real-time agent progress. And finally, we have our main server endpoint. So the agent instance bootstraps that wires up the reasoners, the skills, the schemas, the SEC streaming, and exposes them to a production-ready HTTP microservice. Now, let's understand how this entire project basically puts together. So in our source init.py, it basically creates one shared app agent from the AgentField package, and that object is both the LLM runtime and in this project a fast API style server that you can start with app.serve. Now, inside of skills.py, the app.skill registers deterministic tools. For example, in this case, it'll be Yahoo Finance, and AgentField exposes them as HTTP routes, typically under skills/. Then if we go to reasoners, we have another decorator, which is app.reasoners, which registers named pipeline steps with paths, for example, /research. And these are the things that actually show up on the control plane, which is the AgentField server, often on the UI side of things for tracing. And then within reasoners, the app.ai asks the model for structured output that validates against the specific schema. And finally, app.note is what will emit the human readable progress, and the streaming layer also pushes the SEC events for the UI. So in terms of the data flow, the first things that we do is we define the schemas. And the key here is that when we are calling these schemas in the reasoners, so for example, the schema equal to research plan, when you pass schema like research plan, the LLM does not return a raw string. It returns a typed Pydantic object. So when the manager hands off to the analyst, it's a structured research plan and not just a blob of text. So every handoff between agents is completely type safe, which makes the multi-agent coordination reliable instead of fragile, and is specifically designed for AI backends. And schemas for Pydantic models define the structured flowing through the system. So for example, the manager produces a research plan. Now, when you go to skills.py, so as mentioned, that skills are these async functions that are decorated with the help of app.skill, and they wrap the y-finance in a thread pool. So the blocking IO does not stall the event loop, and the return values are generally JSON friendly dictionaries or even lists. And we have a bunch of different skills that we have created. So we have things such as get income tax, we have get balance sheet, get cash flow, market news. All of these are done so that we have a list of articles. So for example, there will be one for insider transaction. This one will be used for getting the recent insider rows, which will be normalized to dictionaries. Then the reasoners are what are the agent field visible steps. They will compose the skills with the app.ai and the schemas. So whenever we define our app.reasoner, we'll be using that specific decorator. And here we will have, for example, the create plan. So this is a post/research/plan, which will be output will be the research plan in a single app.ai call with a system prompt for decomposition. And similarly, we'll have other ones, for example, to conduct our research to synthesize the report. So for example, in the case of synthesized report, it is a single generic editor. Next is editor short term. So this would be used, it'll use the app.ai with instructions of using to get the quarterly income flow or targets or insiders. Similarly, we will have the editor long term, which will be able to use the same inputs, but it gathers the company facts targets for a longer duration, and we'll use the other model here. Then when it comes to the stream.py, this module imports the same reasoner callables and runs the same logical pipeline as plan research, but it basically wraps all of the different steps in emit for server sent events. So agent start, agent node, agent complete, and it uses the context var. So background tasks push to the correct async IO queue, and it defines the post request. So now finally, when we go to main.py, it fixes the sys.path. So Python src main.py can import src. So essentially what we're doing here is we have one process, one agent, and all of the HTTP endpoints which are available to us. And finally, we have the UI, which consists of all of the client. So basically, this is the client for the research/streams.start, and all of the SCC event endpoints rendering the tabbed short-term, long-term report and the reasoning, all of that will come under this index.html. So the mental model is that schemas, as you mentioned, define what each and every agent must produce. The skills define how to get facts from Yahoo Finance. The reasoners define who does which LLM step with the API.ai, the schema, and where all of the parallelism basically takes place, and then we are able to stream it with the help of SCC for live UI updates. So now let's get started with actually running the application. The first things first, we have to run the AgentField server, which runs over here. So you can see that we have already started it. I'll close it and I'll just rerun it again. So in order to run it, you just run AF server, and that will kick off our AgentField server. Next, what we'll do is we'll also run our application. We'll do uv run python 3 source main.py. Alright, so let's start it. Okay, so this is our UI, and here we will ask a question like, should I invest in NVIDIA? And when I click on analyze, it basically starts off the process. So as we described before, that it will now go ahead and start this entire architecture of our application, which has multiple agents. So we have the manager, which will take the user's query, it will turn it into the structured research plan. And then once the plan has been created, the system will break it down into two parallel investigations with the bull case and the contrarian. And then once the analysis are done, we'll have the editor short and editor long to look at the short term and the long term outlook. And finally, these get combined into a dual research report where you get the final hybrid strategy, and it tells you whether you should make an investment or not. So this is what we can see here. that we got, it ran all of the different thoughts and was able to synthesize the result, and it gives us both a short-term look and a long-term look, and it gives us a bull case, the bear case, and finally, it gives all of the key metrics. So after the system runs, we can now show the AgentField dashboard. So now we open the AgentField dashboard. So when we open localhost 8080/UI, the control plane automatically draws the full execution graph.
So now let's take a look at the AgentField dashboard. The AgentField dashboard provides a powerful visual representation of the entire AI agent orchestration, serving as the interface for our control plane. And by just navigating to the local UI on localhost 8080/UI, you can see the system's underlying infrastructure in action, moving beyond that simple script execution. So let's take a look at the main features of our entire dashboard. So first thing is that the control plane automatically renders your full workflow graph, which can be seen here inside of the workflow executions. Now, what this shows you is the graphical visualization of the sequence of our specialized agents, starting with the manager, analyst, contrarian, and the editor short and long. And the directory graph clearly illustrates how tasks basically flow through the system. Now, every node that you can see here in this particular graph acts like a window into the agent's internal activity, and you can inspect the execution time that basically tells you exactly how long each and every step took to process, the inputs and outputs, which is the raw data transferred between the agents, ensuring transparency in the reasoning process. And you can also do skill tracing, because every skill, which is a deterministic function which is called by an agent, is displayed as a child node, showing you how intelligent reasoners leverage specific tools to complete their individual task. And you can take a look by clicking on one of these particular skills and nodes, and you can click on one of these nodes and take a look at all of the inputs and outputs, the execution ID, and the total time it took, and also get some of the technical details such as the workflow ID, the agent node ID, and the reasoner ID, which all gives you valuable information. Now, one of the standout features about AgentField is that you do not need to write any type of manual instrumentation or tracing code. The control plane handles all observability automatically, allowing the dashboard to populate these complex multi-step execution paths without any additional developer effort. So if you take a look here, for example, we have the agent node. You can take a look at all of the different reasoners and skills that have been created. And by going into them, you can also look at the list of all of the recent executions and also the performance marks that have run for that particular reasoner. And going into the reasoners here, you can take a look at the list of all of the active reasoners, and again go back into looking at the success rate, the total number of executions. So get all of this built-in telemetry. And this visualization is intended to demonstrate that AgentField is a really robust AI backend built for production, providing the full auditability and traceability required for enterprise scale systems. So at the end of the day, what have we learned? The main takeaway from this project is that building useful agent systems requires more than just clever prompts. It requires architecture. You need specialization between agents. You need to have structured data contracts. You need deterministic tools grounding the analysis. And you also need automatic execution tracing for an agent running in the background. You need in the infrastructure that traces every agent call and draws your entire workflow graph. And you need to have type-safe hands-off between agents so that one bad output doesn't cascade through your system. And you need to be able to build and chain agents like real microservices, chaining API endpoints. You need observability to understand what the system is doing. And ideally, the agents should run as reliable background services rather than just chat interfaces. So you can easily swap the finance example that we showed for a use case that fits your own product or workflow, and the pattern clicks almost immediately. So again, thanks for watching this video, and I hope you liked it.